अनिल सर, आज क्या बहुत ज्यादा क्लासेस हो गई? आज पार्टिसिपेंट कुछ कम है।
नहीं सर, आज
स्ट्रेंथ
जो है ना
हाँ।
क्लास जो है मेरी तो आज मेरी क्लास तो कोई भी नहीं थी। आज ना मैं वो दूसरे उस काम में इंगेज था।
एक सर मैकेनिकल में
सर ज्वाइन कर रहे हैं अभी
ना। हाँ, कुछ जिसको ज्वाइन करना होगा कर लेंगे। या मैं डाल
हाँ
देता
जी हाँ जी हाँ जी सर। हाँ प्लीज सर। स्वादित्य।
यस सर।
स्वादित्य।
यस सर। हेलो।
Professor Saini sir is about to join. Please.
Yes sir, I will
join. I think he has joined already.
I think he has.
Yeah. Just a moment. He has joined or not?
Professor Saini, good afternoon, sir.
Sir, I think he has not joined so far.
He has already joined, and now I think he again left. He was there.
Yes, sir is there. Professor Saini sir, good afternoon, sir. Sir, you are mute right now.
Okay, sir. Anil sir, by the time please send today's schedule to mechanical group.
Amit sir?
Yes, sir.
Amit sir?
Yes, sir.
Sir?
Yes, sir.
Sir has already joined, sir, I think.
हाँ ठीक.
Okay.
We welcome Professor Saini.
Hello, Ankit, is audible?
Good afternoon, sir.
Hello.
Yes, very good afternoon, sir.
Good afternoon. Good afternoon, sir.
Thank you, sir. Thank you for joining.
Am I audible?
Yes, sir, you are audible.
Okay.
Ankit,
Yes,
now
sir.
you may start.
Yes. Now I'm going to introduce second speaker of today's session, Dr. R.P. Saini. Dr. R.P. Saini, sir, is professor in Department of Hydro and Renewable Energy in IIT Roorkee. He has 35 plus years of teaching and research experience. His research interest is in the field of small hydropower, solar energy, and integrated renewable energy sources. He published more than 135 research papers in national and international journal and 207 symposium, conference, and seminars. He also do some international projects. Some of them are UNDP-GEF Hilly Hydro Project, New Small Hydro Option, R&M DPR with Canada, Training and SIDA SHP Technology Transfer with CanMat, Canada, training of SHP projects in Nepal and Bangladesh, and many more. He is life member of International Association for Small Hydro, life member of Indian Society for Solar Energy, etc., and many and etc. He holds two patents. One of them are a horizontal open cross flow turbine, patent number 230527, dated to 27 of February 2009. And second one is water mill used for grinding grains, patent number 231697. In 2009, he received many awards such as Dr. APJ Abdul Kalam Award 2018 and Bharat Excellence Award in 2018, Friendship Forum. He also received Lifetime Achievement Award by Venus International Foundation in 2016 and many more. He has guided a good number of research scholars in successful completion to their master's and doctoral degree. Now over to you, sir. Sir, please.
Thank you, Ankit. We also welcome our HOD, Professor S.K. Garg has also joined. Welcome, sir.
I welcome all of you and Dr. Rajeshwar Saini, sir. Good afternoon and welcome to. It's our pleasure that you have accepted our request to deliver a session.
My pleasure.
And topic is very interesting, and with your experience, I think everyone will gain out of it. So welcome, sir.
Thank you. Thank you very much, sir. Thank you, Professor Garg. And at the outset, am I audible, sir?
Yes, sir. Yes, sir. Very much. Very
Okay.
nice.
So, at the outset, I just thankful to the coordinators of this program, which is being organized by Delhi Technical University, basically on alternate energy source for sustainable development. And now I want to share my
Sir, I think you are muted. We are not able to hear you.
Hello.
Yes, sir. It is visible, but you have to make it full screen.
Okay. Now it's okay, I think. Hello.
Yeah, it is not in slideshow mode, sir.
From my side, it's okay.
I think you may try by pressing F9 or slideshow.
This I want. It should be full screen now. Yes. I think it's okay now. Hello.
Sir, I think though it is not in slide mode, but it is quite visible, sir.
Okay.
We can continue with this.
Yes.
This happens sometimes.
I think, sir, it's fine, sir. It is very much visible to all of us.
It's not getting changed, no? Now it's okay? Hello?
No, sir. No, sir. Still, sir, I think it is fine, sir. It is quite visible. No problem, sir.
It's visible.
Yeah, it is fine. Yeah.
Okay, okay. So we'll manage like this only.
Yes, 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 yes.
Okay, thank you. And I'm sorry that because some issues came.
No problem at all, sir. No problem. Yeah.
So, good afternoon once again. So basically, this topic given to me, that's integrated renewable energy system for sustainable development. So I'll be talking about just before I just discuss the sustainable development through integrated renewable energy system. So I'll speak about some basics about the renewable energy and the resources, in particular in India, and what is the potential we can have, or we have assessed, and the related technology also, because that is also play the this important role in order to because there are so many technologies related to integrated renewable energy, it's emerging technology. So here, then with the basics, I'll start with that because we all know that the energy resources can be classified. Basically, they are, sometimes we use the terms the conventional, non-conventional, sometimes renewable and non-renewable. So the basis is that if traditional use, that because now this conventionally which is being used, that is known as the conventional source of energy, and non-conventional source of energy, which we are just started using that. And based on long-term availability, this is renewable and non-renewable. So we just come to this that how we can define this renewable energy sources. So we all know that about that. This because the non-renewable, they are not replenished after use, because if you consume that source, that it will not come back. But this renewable energy sources, they are naturally replenished after use. So that is the advantage, and that's the beauty with this, because we don't have any problem with the quantum. And of course, we have substantial use of this non-renewable energy. We are afraid of that. We have fear that after long use of this, this will be vanished. But that is not the case of the renewable energy. So in India, we are lucky, or we can say that we have a lot of renewable energy sources, especially the solar energy, wind, biomass, and hydro. And so in among this solar energy, we just falling in the region in the world, that means where the maximum intensity of solar radiation or maximum amount of solar radiation we intercepted over the Earth's surface of in the Indian region. So, and wind also we have, but of course this is very, very site specific. Biomass, of course we have the hydro. We have that the huge amount of this hydro power. So I'll be talking about this because in this 1.5 hours I cannot discuss that how we can estimate these resources and what are the basics behind the technology. But I'll be talking about something about that, what is the potential and that's related technology. And finally, I'll be talking about the integrated renewable energy system. What is the need of the this integrated renewable energy system, and what is the how we can start working in this area, because we have a lot of scope in that. Especially, I'm talking about that if you just talk about the this grid system, connected system. There's okay, we can rely upon a single resources, but in remote areas where this grid is not available, so there we can say that the role of the integrated renewable system comes, and then we can say that there's a sustainable development through this integrated renewable energy system. This again the overview I'm giving, this global electrical power scenario. Here we also know that even in worldwide that about 64% or more than 60% still we are rely upon the fossil fuels, and you know that there's a lot of the disadvantages. Apart from that is fixed quantity, but we can say that the environmental issues are there, this global warming, and you can say that the CO2 emissions problems are there. So that's why we have started, or the world have just started thinking about the renewable energy. And I'm talking about in India. So we worked in the wind energy exclusively, in the hydro, but after 2010 and this 11-12, when this Jawaharlal Nehru missions came into existence, then we started working in the solar energy, because we have a lot of potential of solar energy. This is the things you can see here. That means if we predict that what is going to happen, that we will be happy that, because still this trend of these energy consumption by different sources is like this only. But we are hopeful that after 2040, that means we hope that this renewable energy, or the energy generation through renewable energy, will be overcome all these fossil fuels. So that shows the trend. And this is I'm talking about that the similar situation we have in India also.
Sir, not audible.
Fulfill our requirement through renewable energy sources, so that all the environmental problems or the CO2 emission that can be solved. This impact I can show here in this slide. Of course,
Sir, PPT is not there.
it's not there.
PPT, I am not able to see. I don't know whether others are seeing or not.
It is
I
not,
am not.
sir, since last 2
No, it's not.
you have started coming.
Which slides?
Just go to your presentation, sir.
I think again you have to present.
Right. This is visible.
No, not right now.
That's the problem. I don't know what to do that. Is there?
Yes, now it is there.
Okay.
Yes, sir. You have completed, I think, 6 slide. You may have to go to
5,
slide
7, 4, 5, 6. Huh?
Yeah, this we have discussed. I think you may go to
Okay. So then this I just discussed that the still we in India also we are still rely upon the fossil fuels, and about more than 64% still we are generating through fossil fuel. So we have to reduce this share with the renewable energy sources. Is it visible? I think. Hello.
Yes, sir.
Okay.
Yes, sir.
So that the things, as I told you, that when we started developing the solar PV based plant, so then this share of the renewable energy is going like the trend is like this only. So that means we hope that up to 2040, we will be comfort. That means most of the share of the renewable energy consumptions or the energy generation will be through renewable energy sources. The impact, I'm just giving that because I'm telling you that since 2000, after 2012 and 14, so then this CO2 emission, you can say that the increment of emission from 1990 to 2000 is around 13%. I think we can see over here. And it was maximum almost double during 2000-2010 period, which is found as 25%. And now, from 2000 to 2017, it is only 7% increment because we have started developing the solar photovoltaic plants. So that means that is the impact on CO2 emission we can have. So similarly, we have to increase the share of the renewable energy sources in order to generate the electricity or the energy consumption. Okay. So this role of the renewable energy in sustainable development, I did these few points I'll read here so that we can have the importance of the integrated or the renewable energy. The renewable energy has an important role to play in meeting future energy need in both rural and urban areas. So here, I think both way I can say, but when we are talking about the integrated renewable energy system, then I'll be focused. That means that the focus is on the rural areas where we don't have this grid, or you can say the electricity or the conventional source-based generation, power generation. So there, the integrated renewable energy in the rural area. But of course, the role of renewable energy in rural and urban areas. The development and utilization of renewable energy should be given a high priority, as we all know that, especially in the light of increased awareness of the adverse environmental impacts of fossil waste. Okay, the need for sustainable energy development is increasing rapidly in this world that already we have discussed. Widespread use of renewable energy is important for achieving sustainability in the energy sector in both developing. That is there. That means the role of renewable energy is we have to consider. And here only I tell you that means in both ways we have to develop some mechanisms in order to just assess the potential. It's still a lot of work we have to do that. We have some data that how much particular renewable energy sources we have, but still that data are not that much reliable. So that means we have to work so that we can come to know that this exact value or near the right estimations. Why I'm talking about this? That means based on the estimations, then that will encourage us. That means we have the substantial amount, and if you know the estimations, the potential estimation correctly, then there's a chances that we will have the optimal design or the development of the technology. That is very important because the engineer's task is in the area of renewable energy, that to convert the basic form of energy into useful form of energy, and that conversion device is we sometimes call the prime mover, and that can be optimized. I'm talking about it should be efficient, it should be reliable, and it should be cost effective simultaneously. So that means that can be possible if you know the correct estimation of available source of energy, that is the available amount of that the energy of that particular, the potential of that particular source. So that is very important. That means here I'll be giving some points. That means where is the scope of doing research as the academic the point or R&D point of view concerned. So a lot of scope is to devise, to develop the model so that the various, even you talk about the wind energy, we are relying upon, of course, that based on the some this weather monitoring stations, but still some model we have to develop because based on the various assumptions we are estimating the potential. Similarly, the solar energy also, biomass also, so that means there is a scope of this thing. Then in particular, I'm talking integrated renewable energy system. So there is these last 2 points. I can say that they favor, that means system decentralization and local solutions that are somewhat independent on the national network. I think this is the things I'm talking about, because the various industries, they are developing the sizes of the systems or the technology or the device there for the large size, which may not be useful there, which may not be cost effective in the rural area where we have to work in the integrations of the renewable energy sources. So that means we have to think about the smaller size. So the small scale of the equipment often reduces the time required for initial design of operation, providing greater adaptability. So that is the things we have to think related to integrated renewable energy system. So these points also, I think these are similar points we have to think. The only thing these points shows the importance of the integrated renewable energy for the sustainable development. Now, as I told you that I will just give the brief about that. What are the sources and the potential, and the technology related, and some issues related to technology which we should think as the researchers or the academicians, and which we can communicate our students that they can start working in the renewable energy, in particular integrated renewable energy system. So I think this picture, you can see that here. So when we know that actually the sun is the prime source of all the renewable energy sources, and here if we are talking about the solar energy, because we are not interested, of course it is useful to grow the tree that is indirectly used for the hydro cycle, for hydropower, for wind energy, uneven temperature, but as far as the solar energy concerns, only 47% of the total solar radiation which is emitting from the sun is reaching to Earth's surface. So our concern is to tap that. Of course, only this a very small fraction of that we can tap that due to the environmental this atmospheric conditions around the Earth. So just have the idea. That's you the idea, because of course these figures are dynamic figures and we have some basis. So for example, that when we had the technology related to wind energy, that means to install the wind turbine about maximum 80 meter this high tower, that time it was about 1 lakh this megawatt. But now we have the technology which we can install our turbine that over a more than 100 meter this high tower. So that means the potential, because you know that this the wind speed is it depends upon the height. So now that's why I'm talking about. It's similarly solar energy we have estimated the 7,50,000 depending upon the considering the available land, and because it is basically depend upon the Earth's surface or the area. The small hydropower up to 25 megawatt in India, we have the definition of that. So it's a 21,000 around 21,000 megawatt. Biopower, we have this bioenergy, agro-residues, cogenerations, biogas, waste to energy. So that means this table shows that, and I tell you that very small fractions only we could tap so far. If you look at the power generation, so there that means lot of potential which has already been identified. Only things we have to tap that, and I'll be discussing something that what is the hindrance to do that. So quickly, I'm talking about just solar energy. As I already told that we are lucky. This that about 5 to 7 kilowatt hour per square meter per day. That's the average taken over the 24 hours. So it's good enough, or I can say it is the maximum in the range of the maximum solar radiations of the solar energy. That's 4 to 7 kilowatt hour per square meter per day. So there's no related to that. So simultaneously, I'm talking about little bit about the the technology. So this solar energy can be tapped by two different routes, and this is the beauty with this solar energy, that if you need the thermal energy, that can be directly converted to heat energy, and that is the only source where we can generate electricity without having the conventional generator. That's the the conventional generator. So that is also there. So here two different routes we have to we think about. Uh, if we talk about the integrated renewable energy system, so the sizing of solar photovoltaic system is very important, because as far as if you are designing, if you're sizing the solar photovoltaic system for grid connected, then there's no problem. That means it depends upon the how much money you have and how much area the land you have, so you can. But when you talk about the off-grid system, then the sizing of the PV system, of course, is a big or the extensive exercise you need in integrated renewable energy system. And as I told you that still we are lagging in India, that because we don't have much, or I can say not even single or you can say the large size plant, solar thermal plant. So we should think about that also because in other countries like Spain and America, they have maintained some ratio between the solar photovoltaic and the solar thermal system. So otherwise, that's the problem we are facing. We have started facing that storage problem. So whatever energy through SPV you generate, that you have to put in the grid, and that we don't have, even we are facing the reliability of the grid. But in case of the solar thermal, that can be used for the peak energy based plant. We can store, that is, storage is very economical in the solar thermal system. So we have to think about that. So it's simple. That means the solar thermal route is through solar collector. They're basically this flat plate collector or focusing type solar collector. And in India, we are using we are tapping the solar energy through this solar thermal route by I think mostly for heating purpose. It's a low temperature, so hardly any plant. So that lot of scope is still there. So even I can say that still we don't ready to generate the electricity through this route, but we can have the high temperature system. We can develop the high temperature system. There's a lot of scope in that, and this route is basically for low temperature. This hot water system, mostly in India we are talking, or some area we are using for drying purpose or heating purpose, but mostly hot water system. But still a lot of scope in this for high temperature. This is there, that we have the various type of focusing type solar system, but still we have to do in this area a lot of things we have to do. And I say that we must do something. We must start developing this plant. Of course, we have the main thing is nowadays we are very much concerned about the how much gigawatt immediately, how many year per year, and these plants, of course, they are the, you can say, the real engineering plant, we time consuming also, and so that means it is not coming up. Then of course we have some data, this off-grid decentralized solar PV system, because initially these are the numbers we have. Of course, this is available on the MNRE site, so I have collected from there. And the solar power projects, that means year-wise, and the total this cumulative capacity till 2018-20. That's this. So that means this data are available. As already told you that we have comfort. That means we are going with the good pace at least in the solar energy. And this is based, as I told you, that this is through this national solar mission we have working in this. Similarly, this wind energy also. So this wind energy, you know that of course the site is specific, the coastal area like in Tamil Nadu, Gujarat, there we have, but still we have the good generation through this solar, wind energy. So, but there are some issues are there. Basically, as I told you, that lot of scope is to even estimate, or we have to for developing the models to estimate the wind potentials. So in other area also, so we don't have the reliable data. So that means if we have the reliable data, so accordingly reliable data of the potential, wind potential. If we have the reliable data, accordingly we can size the system so that the system can be developed in cost effective manner. And it is very much required in off-grid system, because we don't need that megawatt wind based system. We need about this aerogenerator, maybe 2 kilowatt, 5 kilowatt, 3 kilowatt. So still we don't have the such system. So that will be based on that if we develop the model to estimate the potential in different area, in the remote areas. So this is the data taken from the site. It's available at the MNRE site. We can have, so that means as far as the potential of wind energy concerned, there's no problem. And this quickly, I just tell you that we have this the wind system. So almost I can say that for power generation we have this propeller type turbine, and we have other type of turbine, this cross flow or this Darius, Savonius. These we have. Here I'm trying to connect here this technology, or you can say that the turbine. The similar turbine can be used to tap the hydro potential also, which is available in flowing streams. So that means again there is a scope of working. Of course, it's not that this technology has not been the systems are not have not come up to that large size, but in remote areas for pico hydro, say 5 kilowatt, 10 kilowatt, 20 kilowatts or 100 kilowatt system can be developed by using this wind energy technology directly. It's a similar turbine that all kind of turbines can be used for tapping the potential of hydro available in the flowing stream. So we have a lot of potentials in our canals. So that's the scope I'm giving here to that in the quickly. Otherwise, we have the propeller type system only. Then hydropower, of course, we know that how this conventionally I'm talking about. Conventionally, the hydro potential which is available in the form of head, the pressure, and that has to be converted into mechanical energy through turbine, and the turbine connected to generator, and that's there. So it's a well proven, I can say the developed technology we have in India. And the turbine, if you are talking about the turbine, which is considered the heart of any hydropower plant, where this mainly this energy conversions take place. So we have the technology to develop the turbine, say up to 94%, 95% turbines are available. So that means as far as the technology concerned, we have this technology is matured in India in that. So, but again, I'm talking about, say, for large hydro. For large hydro, it is okay. We are comfort in the technology, but still, when we are talking about the integration, the integrated renewable energy for remote area, just for pico hydro or the small hydro is small hydro 25 megawatt, but I'm talking about the this micro hydro, at least, and the pico hydro. So still there is a scope to develop the standard machines. Still we are lagging behind because the manufacturers are not that much interested to develop these turbines of the small size or the pico size or the very low size, because there's not the potential. So that we have to create the this manpower, or you can say the persons. We have to train the local people by using the local this technology, so that we can develop the small size turbine, the things. So still there's a lot of scope, and I tell you that if you just apply, if you try to apply the scale down technology to develop the machines, so it cannot be accepted in engineering or the technically it's not good. So again, we have to think, if we want to develop the small size machines for integrations of the renewable energy source in the remote area. So then we have to start from the basics, from the grassroots. Then only the technology can be cost effective. So that is the point I'm because many people, they started working locally just to scale down approach, that cannot be, especially I'm talking about in hydropower. Solar energy, there's no problem, because that the size is directly proportionate to the capacity. You just buy 2 panel, 3 panel based on the requirement. But for these hydro machines, that is not. You have to develop the things. So again, I'm not going to discuss this various these turbines here, but it's there. That means we have basically, because the potential of hydro depend upon the various types of sites, because it's a multiplication of head and discharge. That's the quantity of water in the head. And if I have a site where the very high head is there and less amount of discharge is there, the water in the stream is less, even then I can use, but the machines will be different, the turbine will be different. If I have the huge quantity of water flowing say in the canals, and the head is very small, so the same turbine cannot be, we have to design, we have different type of turbine. So accordingly we have the Pelton, Francis and Kaplan turbine. This as I already discussed this, in India, hydropower plants of up to 25 or below capacity are classified as small hydro, which have further been classified into micro, mini and small. So I'm talking about for integrated renewable energy system, because I just give I'll discuss the exercise, that how we can carry out the integrations, this exercise for the remote area, for the that there we can discuss that why it is important to work for smaller size. I tell you that this MNRE, basically nowadays the hydropower is of low priority in the MNRE. But still this government is very keen to develop the pico hydro system. That means this off-grid systems in hydro. So there's a lot of scope. There's incentives also. The projects they are giving just in a remote area, so that you can tap the potential of hydro in the remote area and develop these the sites of say 10, 20, 15 50 kilowatt or 50 kilowatt, and to just give to power that remote area. So still there's a scope, lot of scope for this in the micro hydro range. This again, this just biomass. I think here this you know that this, the advantage of this particular biomass, that comparatively it's not that much time dependent like solar energy or wind energy on hydro, but we can store that. So that is the advantage it has. And of course, we have different route to generate the power through this using the biomass. There's a gasifications, we have the biogas plant, and we have this biofuel also. So nowadays, here that actually technology I cannot discuss here in this because the time shortage. But I just ask that if somebody really wants to work in the area of renewable energy, so those points I'm just giving, that there's a lot of scope and they can start, and even government is very much interested in that. So and there's some issues we have to review. Take the example in this biomass, that biogas. I think in 1980, that technology generating power from through this biogas plant, it was well developed technology, and there was no flaw, and still the same technology can be used. But I don't think where it is gone. That means you can think about this, because I know that in our childhood with that there are many plants, that means 10, 15 plants, the biogas plants in every villages were there, and we saw that the plants were working very nicely. But I think now that nobody is this using the fulfilling their need, cooking of this, everybody just using the LPG. I think these points we have to think. These points we have to motivate the peoples that how we can reduce this fossil fuels. But you know that sometimes it happens. The government is also encouraging to use this LPG, and when LPG is easily available, or you can say that cost, I don't consider that. But then they reduce the they reduce the using of the renewable source of energy. So that point, sometimes we have to think that some policies from the government, some incentives from the government, it depends upon that for the sustainable development. That's why this, I think I'm not going to here discuss, you know, that what is the definition of the sustainable development. So that means there are so many factors in this area. We must think about that and we can tackle them also. So this is the things, of course, I'm not going to discuss all this. That here, that this potential, it's available on the website. I think you can see this. I'm going to share this PPT to you. So that means you can see from there. There's nothing to discuss special in this. So as I told you, the technology related to solar energy, we have the combustion, we have the cogeneration. Of course, that's the cogeneration in India. Our government has started working in this, and we got some success in this cogeneration. But it's still biofuel. That means you can see that the farmers, I think in our region, like I'm talking about this in Western UP, so that the conditions, or you can see the price of the sugarcane, the farmers, they are crying for that. But what about if we just produce the biofuel from the? So then we may think that. So the government has to frame out some policies, guidelines, so that there's a lot of scope in that. Then we can say the farmer will become very rich if we started producing the fuel from the sugarcane. So this way we have to think about it. So okay, this is the normal, this biogas and this gasifier I'm talking about. This is biogas, as I'm already. This is the two systems. I think I think long back, 40 years back, we had two design of biogas, with the KVIS and the Janta, and still there is no flaw in this technology. They are very efficient, but they totally stopped. Why? Because LPG is available to every household in the villages. And I just tell you that I don't know you like or not, but in my house, that in my village, it was installed into 1978, and still it is working. That was the Janta fixed dome type. Still it is working. So that means these are the points we have to consider. Then, if some technology which is that may play the role in the sustainable development, then why we have stopped that? So these points we have to think about. So anyway, this challenges faced by the renewable energy industry, that political pressure, you know that the government policies, corporate influences, age-old infrastructure, and the lack of proper storage system and present market scenarios. So despite these factors, renewable energy has undertaken a global adoption as a means to alleviate climate change. Of course, that is, we are repeating this many times. It is free of direct pollution. Okay, so that these are the points we have to think. I think it's a self-explanatory. You know that what is the political pressure, the government policies and corporate. So these points